All right. Okay, so here we go. Crystal Long has been an MVP in the Microsoft program since 2006. She posts on several forums as Strive for Peace. She teaches in virtual classrooms and guides individual developers whilst they're building applications. Crystal's website, which is AccessUserGroups.org, contains a lot of free code, tools, videos, and articles. And you can visit her YouTube channel, which is Learn Access by Crystal, where you'll find lots of Access videos and some other Access topics, or excuse me, Office topics. So what I'm going to do then is make you the presenter. I'll make you the host. Now we see your screen coming up.
Okay. That's nice. Okay, that's really nice. So we'll get started in just 1 minute, and I guarantee it'll be worth your wait for the minute.
I'm really looking forward to this. Yeah. So while we're waiting, a couple of our regulars emailed me earlier today that they apologize they can't make it.
And I did forget to pop out my chat. So Adrian, if you wouldn't mind putting the link in the chat so that other people can download what I'm going to present.
One you sent me earlier?
Yes.
Will do.
Will this be worth its weight in AG or AU?
Thank you, Kent. It's so nice of you.
Yeah.
It don't matter to me if you take, oh, that's the real word, sorry. There is matter in me. You are also made of matter just like me. Atoms are arranged in different ways. Here you will find what is defined. So this is our periodic table of the elements. And as you all know, Access is the most awesome tool for keeping track of information of any kind. It can link, well, I can have it internal, such as it is here, but link to like the world. And so this presentation, actually, it's an example database, uses the elements. The elements are what we and everything that we know about is composed of. And here is a very clever chart showing a periodic table of the elements called periodic, because it was discovered by Mendeleev, I believe, that you can figure out what the behavior of an element would be based on its atomic number and the number of electrons in its valence shell. Valence meaning its outer shell, and the most reactive one. So Access drew this, and I'm going to kind of back up a little bit. So before we jump into this, which is kind of complex, the sample database that you can download has several sample reports. And I'm going to open up a couple of these just to show you some things that you can pattern after. So this report shows you, oh, and here, let me kind of make it a little bigger so that you can see what's going on. Oh, well, maybe this is not a good one to start with. Okay, this one shows you about the draw mode, which is like the one thing I didn't quite understand. There's different properties and methods. So let me pull up my web page about the report draw that I made for you and for me also. So this is what Adrian posted in the chat. It's a reference for all the report drawing commands. And I've arranged them at the top by method, and then by properties, and then functions that you might want to use or get to know about so that you can take better advantage of the methods. So the example that we're looking at right now is about what the different draw modes do. And like I said, this is like the one thing that I probably actually wouldn't even use, but here it is. So I have a couple tables in this database, actually 4 tables that start with enumt, and those enumerate different values of the properties that relate to how a particular method will behave. So this one is draw mode, and I probably wouldn't even ever use that, but it just happened to be the first one that I opened. Let me make sure I'm sorted by name. Okay. In this database, let me just show you the relationships diagram. We have elements, that's the main table. And then elements have groups that are associated with them. So here's groups. And then elements also have a classification. And then they have all kinds of other properties that have been measured. I put a few, just 2 in my property table. I actually have more, but I deleted all the rest of them just to only have the properties that are actually being used by this database example. And then here are the values, and properties can be all kinds of different data types. So what these fields correlate to is the data type number. And if we actually open the data types table, then you'll see that, like Boolean is 1, and byte is 2, and integer is 3, and so on. And that's how come these fields are named the way they are. And then I have these enumeration tables. These are the different fill styles that you can use for drawing, the different draw styles, such as dashed or dotted or solid, the different draw modes, which I just showed you, and I don't really understand why I'd ever use this. And then just different QBC colors in case you don't want to use RGB. So let me go back to my reports. All right, this report comes mostly from the elements table, and it tells you what the symbol is and just a few different things about the element. And then here's what the drawing did. The drawing, oops, where did that go? I just want to minimize this so I can make this bigger. So this has an atomic number of 1, hydrogen. It's our lightest element, which means it has 1 proton and 1 neutron in the nucleus, which is this middle part. And then orbiting around the outside, we have 1 electron. And the outer shell, just so that you can understand, is the reactive shell. And mostly, unless it's a noble gas, in which case it isn't reactive. But this shell actually wants to have 2 electrons. So in order to be happy, it can either give away its electron or get another electron from something else, or share electrons with something else. So these diagrams show you what this atom looks like, and they're sort of proportional. And I say that because in order to actually see the nucleus, the electron would be minuscule because it's about 1/2000th the size of what's in the middle of a the nucleus, which are protons and neutrons. But nevertheless, these do increase size of the nucleus as the atomic number increases. And all these diagrams were drawn with Access, so you can see how they were done. And the first shell just is wants 2 electrons. Now the second shell wants more, so that's why we see like a bigger circle around this. And like I said, Access drew all these, and you can take a look at the code. Lithium, of course, you know, you hear about electric cars. Well, guess what? Their batteries depend on lithium. And now you can see what lithium looks like. And you can go through this report and see what all of the elements look like. And I won't dwell too much on this, although I'll go to the last page of this report. And it takes just a little bit of time to get there because it's having to draw all this stuff on the way. And the most heaviest element that we know about is oganesson. I'm not sure I pronounced that properly, but its atomic number is 118. And actually, we haven't found it occurring naturally, but we have synthesized it in a laboratory. So as you move on through this chart, you'll see a representative diagram of this, and all the circles are drawn with, guess what? The circle method. And all the writing is done with the print method. So you can take a look at this and see how things were done. Now, this report is mostly just a report that comes from tables. We have an elements table where we have the symbol for the element name, its atomic number, its atomic mass, and the way that it's colored. Now there's a couple different ways of coloring that are actually in this database. This is called the CPK method, where, oh no, this coloring looks like it's actually by classification. Okay, yeah, it is. This method is by classification. So all alkali metals use the same coloring method. This coloring was actually not done with drawing. The only thing done with drawing on this report is the border. So the border, the line method can be just a line across, where you give it a beginning coordinate and an ending coordinate, a coordinate being an XY set of values. And help is kind of wrong with this because help doesn't recognize, well, help is like really wrong in most of these drawing examples, which is one reason why I made the web page, so that I could get better help and also give you better help if you actually want to do drawing. So in the line method, if you give it a beginning point and an ending point, then you can specify that instead of a line being like diagonal from that point to that point, it can be a rectangle. And so you can give it an option of B for box. And this border was actually done by putting 2 boxes. One is the shadow box, which is done first, because in drawing, everything is on top of something else. And the second is the actual box, which was done second. This report just shows the colors of the element in the 2 different methods that I've got in this database. One is coloring by a particular group, like how it is classified, and the other is CPK, which has an different color for the most part for each element. But the reason I included it here is because after the report is drawn, now we're going to do a vertical line from kind of from top to bottom, from top underneath the headers, and then we're going to use a vertical line across. So this shows you examples of drawing horizontal and vertical lines. Now this one, which is the first report I showed you, and the first one I actually did to give you an example, uses the line method, and it uses the B and BF actually for box fill, so that we can color each one of the elements differently. And the sample database has the code to do all of these things. Draw style shows you if you change the draw style property, what happens. And the reason why I gave you an example with different widths is because after about 3, usually it's supposed to be 3. I mean, help says it'll be 3, a width of 3 pixels. It says after that, it's a solid line. However, I did find a few examples, or one anyway, where 4 was still the pattern. So here's the different patterns and what they're called. This is just in case you want to do dash lines or dotted lines, so you can look something up on this. I'm going to close it. I'm going to close these reports that we've opened up so far. Draw width. This is the draw width in pixels. Now you can change the unit of measurement. However, I like to just keep it the default, but I don't always keep it the default. In this case, I did. So this is 1 pixel, 2 pixels, 3 pixels through 20, just so you can get a relative idea of how thick your line will be when you draw it. And this relates to not only the line method, but also the circle method. Now, here we have the different line styles. So opaque is just, solid, and default, transparent. These all have fills. So this is horizontal fill. Now this is really useful, like if you're wanting to draw something and represent colors differently, because maybe it's going out to a black and white printer, such as, certain types of charts. If you were to do charts with the drawing tools instead of using the built-in chart methods that Access has. Here you can do horizontal lines, vertical lines, diagonal lines, crossed lines, and diagonal crosses. So this is just to give you an example of what all of those look like. Here's an example of different kinds of colors that you can use. Now this one is just using QB color, which is 0 through 15. So there's 16 different choices. However, you can also use RGB colors, which give you an even greater variety. But this is just using box fill and changing the color. And this is just to show you that it doesn't matter if you use the detail format event or the detail print event, they both just get the same thing. And help is just so wrong about where you can use things, because where you can use them is lots of places that help doesn't tell you. Now, this example is just box lines, and it uses the same code in the detail event, which draws the box around each one of these detail sections, as it does the page event, which just uses a different color around the whole page. So the code, it's just depends on where you call it from, how wide the area can be, how tall the area can be, where it starts and where it ends. Now this example, as we, what it does is it colors the even rows with it makes or draws boxes in the even rows and draws lines in the odd rows, and it changes them according to which row it's in. And you can take a look at the code, but here we have kind of an interesting pattern, just showing you what the line can do. It can draw rectangles, it can draw lines, it can draw horizontal lines, vertical lines, diagonal lines, the boxes. If you specify that you want your line to be a box, instead of drawing the line from the beginning point to the end point, it just uses those to draw a rectangle. And then this, like the other examples that have detail and page events, it is calling the same code from the detail section and the page section, sending it the color to use. And as you can see, page goes last. So in this website, a web page that I gave you, if I go to the top of it and I go to the order of events, we'll see that first it draws all the format and print events for the various sections. And then finally at the end, it does the page event. So anything you have in the page event is going to go on top. And I don't know if you can actually see this, but the page event is drawing these lines on top of even the data that's on this report. And each of these events just draws the same, uses the same code to draw diagonal lines from its boundaries, and then also tell you this also uses QB color. Not that I ever really use that method, but I just thought it was a good one to use for an example because there's only 16 of them. So, and they, you know, they're all different. Now I'm actually going to go into the code behind one of these. And let me ask you a question, because I know I've just kind of gone through these really quickly, but which would you rather see first? Would you rather see how the periodic table was done, or would you rather see an example of line, or would you rather see an example of circle? So I'll give you a moment to compose which you want to see, line or circle, and that will drive which example I show you the code for first. And hopefully somebody will offer a suggestion.
You want it verbally, Crystal?
Yes, please, because I didn't pop out the chat.
Okay. No one's actually said anything apart from me in the chat. So I was going to say circle because you've shown a lot of what a line can do. If anyone disagrees, shout up.
I would say circle is probably more interesting.
Okay.
Cool.
All right. So let me choose. Well, now you can also use this filter. So you can go to circle here and filter for circle. This is the help for circle. Now I didn't show you these. I think the VBA that help has is kind of not really all that great, but I did put a few of these in here. This shows that now using the circle method, we can either make a circle, we can make an ellipse if we give it an aspect, and we can make an arc. Now the arc can also have solid lines between the edge of the circle and the radius if the argument has a negative value for the angle. Now keep in mind, the negative value for the angle doesn't mean it's going to be negative. Negative is just an indicator, meaning that you do want it to extend the line from the circle to the interior. So that said, and that's kind of why I included this, was just to show you that. let me go to the design view of this report. Oh, hey, no controls. What's going on? Let me show the code for this. And how do I get this box at the top to not take so much space? Well, here we go. I'll go to the module for this. Sorry for this roundabout way of getting there, but my screen is like hidden on the top with some of the Zoom stuff. So as I go through this code, I'll just kind of show, oh, not this one. Save the changes. This one. As I go through some of this code, I'll just show you what this looks like in its report view. This is circle element. So let me get the right code up here, and let me just kind of size these so that you can see what it renders. At the same time, I show you the code for that. So this particular report has a source, and in the source, we know what the atomic number is. Now, this atomic number is the number of protons in the nucleus, the number of neutrons in the nucleus, that is given that it is in its original form, and also the number of electrons in its shell. Now, in order to draw these properly, I had to know how many electrons could actually be in a shell. So I have a table called T-shell in here, and this is the abbreviation for it, which I don't use in this example, but we have a shell number. So the first shell can have 2 electrons, and the second shell can have 8 electrons. The third shell can have 18 electrons. So here I also have a column just for the total number of electrons so far, so that I can see, given a particular atomic number, what its valence shell will be. The valence shell is the outer shell. So coming to the code here, on the detail print event, I'm just calling draw atom, and I'm calling color symbol from the detail format event, just to show you that it doesn't matter if you use detail print or if you use detail format if you're doing drawing, because each works in both cases. And unlike help will say, oh, you have to use this in print, oh, you have to use this here, oh, you have to use it there, and help just isn't right about that. So here's just some code to color the symbol. Now the symbol was colored not with this symbol, all right, was colored not with drawing, but it was just actually colored just depending on what the values of RGB were in the table for what to use for the background and the foreground. Now to draw the atom, here's where the actual drawing stuff comes in. And in addition to getting information from the current record that we're on that has information about the element itself, I'm calling in this shells table that defines how many electrons can be in each shell outside the nucleus of an atom, so that I can know how many rings to draw around this, because the lighter ones, like hydrogen, that's the lightest element we know about, just has 1 electron. And then as we move forward in the periodic table, we have more electrons, and how many we can have in each shell depend on its atomic number and how many electrons are in the shell before it. So I'm just going to do quite a bit of math here. And because this is a circle, almost always when you draw a circle, unless you're going to draw like a complete circle, you're going to want to create a constant for pi. And the definition of pi is this magic number of which there's 2 of. If you go around a whole circle, this relates to the angle of a circle. So there are 2 pi radians. Now, radians is a little different than degrees. We know that a circle is 360 degrees. Well, 360 degrees correlates to 2 pi radians. And all of the functions in VBA that have to do with angles use radians, not degrees. So you need to be able to convert between degrees and radians. And then I've just made another constant for inches to twips. A twip is actually means 20 in a point, and there are 72 points in an inch. So therefore, there are 1,440 twips in a point. This is just to kind of correlate my measurement systems here. Defined a bunch of variables. And now a nucleon is either a proton or a neutron. Nucleons are the things inside a nucleus. So there's 2 types of things inside a nucleus, and I'm just using the same font size for both of them. Now, the electron font size I made bigger. That's these little blue circles that go around the outside, just because a minus sign just isn't very big. And I'm setting some other variables here, and I'm giving it the radius of an atom. And ideally, what I would have done is I would have made this relative to where it's being drawn, but instead I just kind of played with this number until the biggest atom fit in the space, and then these are proportional. Then I'm setting just some different colors, the color for an atom, just a gray color, colors that I want to use for protons, colors that I want to use for neutrons, and colors I want to use for electrons. Now, in the beginning of your drawing, you want to set, now I set the scale mode to 1, and that is the default, but I want to make sure it goes back to the default, which is twips, just because all my measurements are in that. I'm telling it that the width of each line is going to be 1 pixel. Now what I'm doing, however, is I'm redefining the 0 point. Normally the 0 point, can you see like my magnification symbol, my cursor up here? The origin would be the upper left corner. The origin meaning that's where 0, 0 is. And then the lower right corner would just be how far down it is and how far over it is. But when I'm drawing circles, I like to put 0 in the middle of the area where I'm drawing. So I'm redefining the top of the scale to be whatever the height is divided by 2. And minus that amount. Originally, I didn't remember to do this minus sign, and it didn't work quite right. But you need to do the minus amount, and that way this top coordinate will be a negative number. And that just kind of made it easier for me to draw the circles. And then for scale left, I just made it the same as instead of saying the scale width of all this, I just related it again to the scale height because that's the smaller measurement. And I wouldn't necessarily have to get the scale height and get these things. I could use these properties actually in the code. However, I like to set variables while I'm using me so that I can just refer to what is the height of the Y. Now Y is vertical and X is horizontal. So this is my little drawing area. Now this X width, that's not the whole drawing area. That's just the area where I chose to start this. So I'm redefining it a little bit. Now, the fill color is going to be whatever is the color of the atom, and that comes from the query that I'm using. Let's see, somewhere I think I said, oh, no. Okay, so that comes from whatever is the color of the atom. Let me see where actually this is defined. Let me go to the definition of this. And oh yeah, I did actually define these colors. I set the color of the atom to be beige. And now I'm setting the fill color to be opaque, because the default when you're drawing is for the interior to be transparent, but I actually do want it to be filled in. So I'm specifying opaque for the fill style. Now I'm calculating the radius of the atom dependent on the atomic number, just so I can make these proportional so they're not all the same size. Then you'll notice that I am inside with me, but Circle just can't pay attention to that. So I have with me up here, but to draw the circle on me, I actually have to say me again. I have to give it the reference for the report, whether it's me or it's a report reference to somewhere else. Circle doesn't work with a relative reference, and neither does Line. And it might just be because they're so weird in their syntax. Look at the first parameter here. We actually have two values. This is X and this is Y. But instead of being like X comma Y, they're in this really weird format. Oh, and IntelliSense doesn't work either. So that's another reason why you might really want to make a note of the help page that I put out there for you, just so you can real quickly find out the syntax for these different drawings. Now, the only thing you need to specify for a circle is the coordinate, which is the center of it, and its radius. You don't need to tell it what color to use. If you don't specify a color, it'll just use whatever the foreground color is already set to for the report. Now, to get the random angles to draw the neutrons and protons, because I didn't want all the nuclei to just kind of look the same, I use the randomize function. And then I set my font size to be the nucleon font size. So it doesn't matter if I'm drawing a proton or a neutron, they're going to get the same font size. I'm going to make it bold. So now for however many atomic numbers it has, which means, so if it's atomic number 8, then I'm going to draw 8 protons and 8 neutrons. And now I'm going to go, this is how many, so I either have a proton or I have a neutron. So that's why J is 1 to 2. And if it's a proton, then I'm going to put a plus sign in the middle. And if it's a neutron, I'm going to just put an N in the middle. And if it's a neutron, I'm going to color it for a neutron. If it's a proton, I'm going to color it for a proton. Now I'm just going to randomize again. And the reason I did this a couple times is because when I first started doing this, they didn't seem to really be very random. And so I thought, oh, hey, I'll just randomize a couple times and hopefully that'll get it to be more random. So this angle, I'm randomizing the angle and I'm randomizing the distance from the center to the edge. Now I can't have a nucleon start until the radius is like at least that far in from the edge. And so that's why it's getting multiplied by this amount. And then I'm just creating a random number. The cosine of a number relates to its x coordinate. The sine of a number relates to its y coordinate. And that way I can get my x and y for the middle to draw it. And I'm going to give it a radius according to whatever the nucleon radius is. And then whatever I'm going to color that. Now, in order to print, print doesn't have these extra parameters like the other methods do. In order to print, you have to already set where you want the text to go. So you set the current X, you set the current Y, and here also I'm changing the foreground color to be the color for text, and then it prints. There are no other parameters for print. And now we're just going to go into drawing shells and electrons. And I'm not going to go too much detail into this code because it's kind of a lot of math. But I will just go take a look again at this report and tell you that all of the code to do all of this is in this sample database, which all of you can download. And although I didn't really discuss too much about the periodic table, I do want to show you that this periodic table can be changed to show you this information for the periodic table comes from a query. So if I were to go to the design view of this periodic table and then go to the code behind the form, which I'm going to just have to do it this way because of the silly stuff that Zoom is putting on the top, so I can't get to it the way I normally would. I can see that at the top of this code, I've commented out, okay, this is where it's getting its information. This is the title I want on it. But if I comment those two things out, and instead I use these two things, so now it's getting its information from a different query and it's putting a different title on here. Now when I go take a look at this, oh, and I guess I forgot to bring that query into this database. Sorry about that, but I guess I could go get it real quick. Well, I won't go get it real quick, but I did want to show you that you can just modify where the information comes from. And that way you could do a query based on something else. And I'll just show you what that would look like. Let me go to my images. And this is what it would look like. So instead of doing the whole periodic table, it's just listing the elements that we as humans need. And I also put elements that lower organisms need to sustain life. Now, there are other elements that we perhaps do need, but they're just not recognized widely. But of course, you know, you might say different. But what this does is it skips all the elements that aren't in the query, but it still positions everything where you would expect it to be. I'll close this without saving it. So I hope that this gives you a good reference for how to draw with things. And I do want to tell you that I do training one-on-one. So if you or somebody that you know wants to learn something that I know about Access, Excel, Word, PowerPoint, Camtasia, HTML, all kinds of other topics, I'll teach you. And math, I'm really good at math and I love tutoring math, although I've actually never gotten paid for it because a lot of times I just teach people because I just think I should, since I know so much and it's kind of my duty to help. But I hope you've enjoyed this presentation, and I would welcome any questions that you might have.
Nice.
Thank you. Was that Kent?
That was Adrian.
Ah, Adrian. Adrian, thank you. Well, you didn't say enough for me to really figure out who you are.
It was a
Yeah.
very short clip. Very short clip. I would just question one thing, Crystal. You referred earlier to radians in the pi r squared business and the 2 pi r business. And I think you're referring to the radius. not
Radius is the distance from the center of a circle to the outer edge. Radian is a unit of measurement.
Exactly.
So radius is a distance, and a radian is a unit of measurement that you can convert to degrees or from degrees when you're measuring an angle.
Indeed, but you explained something as being 2 times pi times radian instead of 2 pi r.
Oh, so I said something wrong?
I think so. Yeah.
Okay, well, that could be.
I mean, it's probably just, you know, as you were doing it, they sound very similar.
They do, indeed.
Crystal,
Go on. No, carry on.
go ahead, Adrian.
Oh, if you, one of the other comments I made was it was about when we do graphs. Normally, when we're at school, we do graphs. X is plus to the right and Y is plus going up. But when you're using printing in Axis, it's X right is plus, but down is plus in the vertical.
Yes. Unless you redefine the center point, which I did when I was drawing, when I was drawing the atoms, because normally X is to the right and Y, positive Y, is down, but that gets a little difficult, and because I kind of like to make the origin in the middle, so I have negative and positive numbers. So there is an example of redefining the scale.
That's a slightly different issue, Crystal. You mentioned that earlier, and it's perfectly fine and correct, but going positive, the bigger the number, the further down it is, which is opposite from how you do things when you're drawing graphs.
Yes.
Exactly.
Yeah, it does take translating the way you look at it to be a little different.
You understand that. I just wanted to make sure that everyone involved understood, because that's not something that would necessarily jump out at you.
Yeah, I think this is one of those cases where you need to spend sufficient time actually understanding the drawing itself, the drawing methods, in order to write the VBA to match. Yeah. So I have one question.
Sure.
You mentioned, well, these examples are based on these specific reports. How flexible are these various functions in terms of repurposing them for other kinds of drawings, for lack of a better word? Can you?
Well, yeah, the ones that the functions that I made generically that I'm calling, not necessarily calling behind the report, but there are some modules in there with just some general functions that I think could be used like just about anywhere. There also are a lot more functions that I've written for drawing that I didn't include in this, just because I didn't want it to be too overwhelming. But I did want to point out on the scale, on setting the scale, if you set a negative number, the coordinates increase in value from bottom to top. So if you did, for instance, want your scale to be starting in the lower left corner, then you could absolutely do that by just setting a negative number. And you could have, instead of, thinking, oh, as Y increases, I'm going down the page, you could think as Y increases, I'm going up the page. So you can translate that to your way of thinking.
How practical would that be, though? I mean, it seems to me like we're used to looking top to bottom when we look at
Well,
it.
it just kind of depends, depends on your perspective. Scientists, they're like think the other way. So yeah, and access, if we're thinking access, we're thinking top to bottom. But if you're a scientist and you're used to just a different way of referencing your coordinates, you can set the scale to be the way you're used to doing it.
So does that depend on the objects being at a fixed location? I mean, if you're printing a page with 3 drawings as opposed to 5, how does that impact?
Well,
Because
it depends on what event you're calling it from. If you're calling it from the page event, like for the periodic chart, I use the page event just because that's the only thing on the whole page. But for some of the other things, I used a detail event, whether it be format or print, it doesn't matter which one you use.
Mhm.
But then your scale is just whatever that detail section is. And if you reference something outside what the detail section has, it just gets truncated. It doesn't expand your section. It just truncates whatever you told it to draw.
Okay.
Ben has a question, Crystal. He was curious about whether with the table of elements report that you do, are they positioned dynamically or are they manually arranged?
In the table where I have the element information stored, I have the row and column stored as well, and that's how they're done. So then I can just make a query, and that's how come I can just show particular elements that are like nutritional elements, because it already knows where it needs to go. And there are a lot of different ways of drawing the periodic table. And I did try to get the most recent way to do things, because depending on what website you go to, you're going to see different ways that it is rendered.
So they're arranged by data essentially, rather than either dynamically or manually. Because you have data that says this goes here.
Exactly.
Can you show us the design view of that report?
Yeah, let me actually go to this table, the elements table, because this is where it's all defined. So here I have the symbol, the element, and here I have the row and column that it's going to go into on the periodic table, along with its atomic number, its group, its classification, its mass. And these are colors depending on, that are individual to each element, but also in the classifications table. Then I also have a color for a different classification. In the groups table, I have also a color for grouping. So, I have to store these color numbers. I could have stored them with RGB, but instead I just chose to store them with long integer.
I think Ben was after the design of the report rather than what you use to print. You print it in code. I think that the actual report design is
okay, so this is the query, and the periodic report table report, just you tell it what query you want it to use, and then it's looking for these specific columns. And the reason why I used atom mass instead of the actual field name is because I converted atomic mass to an integer for that report. So it's not looking for the field name that's in the table. It's looking for a possible conversion. I also renamed row and call and then color fill. So basically, if you filter the sample database for periodic, you'll see the 2 queries that you can actually use. And I guess I renamed this one. Otherwise, it could have the report. So in the code behind the report, I could have actually shown this if I would have remembered that I named it something else after I wrote the code behind the report. But if you just make your periodic table to have this format, it doesn't matter where the data comes from. It can color things however you like.
Crystal, can you show us the design view of the report object?
Exactly.
Sure.
I don't believe there's much in it.
No, there's
Okay.
nothing in
On my
it.
code.
Nothing at all. It's
That's
all
what I'm
done with
saying.
VBA.
So even the header part, the part that's in the center between helium and hydrogen,
Right,
drawing
because
that.
that's S title, and that could be different depending if you're showing everything or if you're showing like just nutritional elements. Or in fact, I can just go ahead and change that right now so it actually does work. Let me go to the code behind this report. And let me rename this. Oh,
commented out.
oh, yeah, well, it is. Oh, okay. Well, I guess I just didn't get the, oh, I forgot to bring one of the queries into this database that it needs. I will update my sample database with that query that it needs, but you can just specify a different query, specify a different title. And obviously the reason this query can't execute is because I forgot to bring in a dependent query that it needs. Does that answer your question, Ben?
Yeah, I guess so.
Yes. So you're
That doesn't sound very definitive.
So let me ask a question a little different way, see if we can come at it from a slightly different angle. You're basically putting all of the controls which show data on the detail at runtime.
Well, they're not controls. And here is where help is really wrong, because help mixes up like help for line control versus help for the line method. And that's another reason why I made this web page, because if you take a look, if you just kind of like bookmark this when you're doing drawing to look up drawing information, in each of these cases, I show you, you know, the help. I give you a link for the help for that, but I also rewrote all of this. This is about 30 pages if you were to print it, but I rewrote all of this help based on what I know to be true, as opposed to what help tells you it is.
The help system says.
Yeah, well,
So you're
help
drawing the
needs
text.
help.
yeah, that was my next question, Ben. Go.
Yeah. I would have expected to have a sub report on there that you move around that already has the font defined in the place for the text. But you're writing the text with a draw command?
No, the text is actually written with the print. So here are the methods that you can use for drawing. You can use line, circle, point, which I didn't cover, but just point if you just want to put a point, or print. Print is how you write text onto a report.
So it writes the text right on the report detail section itself.
Right. With the print, you need to you can specify font name, font size, your foreground color, whether it's bold, italic, or underline. You specify where you want it to start, where you it's a coordinate for starting and ending, and you do all that before you issue print. And when you say print, it looks at all of this stuff. And then whatever you tell it to print, whatever you text you tell it to print, then it'll print that text. And you can alternately add a semicolon or a comma to the end, and that affects where the next starting point will be for the coordinates.
So it'll either put spaces or a new line. If you have neither of those, it'll put a new line. Semicolon means don't add anything, and comma means add spaces to the next tab position.
Right. And you can also specify nothing to print. I mean, this string to print, that's actually an optional argument. It could just be, I want you to go down one line feed.
Sure. Another question. Thank you. Is anyone still curious about how Crystal prints stuff onto that report? Because it's obviously not done by controls of any form. Everything is done from the code using printing, like the print method and the line and the circle, etc. Is everyone happy with that? Before I move on to, sorry, George, I'm nicking your thing, but
that was my question. That was that, and yet it's been addressed. Yeah.
You're happy with that, okay?
Yeah,
because Peter and I both, Peter Bryant and I both asked a similar sort of question. I said, would you mind showing us what would happen if you printed an element with all the circles and all the neutrons and all the protons and all the rest of it, but it's all at that size, it's really jumbled up. And I was wondering if you did one if you could do it on a page size, and Peter suggests one of the more complicated elements, and he's far more into that than I am. Which one did he say? Elements somewhere in the transition metals. So if you could take one of those elements and print it on a page, like an A4 or letter, whatever you do over there, I think that would be extraordinarily interesting to see, because what we see when it's printed is sort of representational, but we don't see the full beauty of it when it's so small. Does that make sense?
I'm not sure I understand the question.
How hard could it be?
Crystal, can you show an orbital diagram for transition metal?
I did make a report. I'm not sure I put it in here. That just has one element. No, I didn't put it actually in here, I think.
If you could show that one element, and a complicated one, I assume that transition metal would be a complicated one, but my chemistry.
Oh, okay, so no,
fill a page, so that instead of
I actually, and let me make a note. I did make a report that just has one element that fills the whole page, and when I was stripping this down, I did not include that report apparently in the samples. Let's see. But if I take a look at the design view of this and I go to the code behind the form, so that's for the whole page as a whole. If I come down to where I'm drawing the element itself, in this particular report, I'm giving it proportional stuff. So there's actually quite a bit of math in here to figure out proportionally how this element would render according to my kind of arbitrary scale that I'm doing. So just so hydrogen isn't the same size as oxygen, so that it is smaller, but it's still not proportional. And I know I'm probably not answering your question very well, because there is quite a bit of math involved with doing these elements. But all I can tell you is, if you're really interested in chemistry like I am, the best thing to do is just look at the code behind this. And I've tried to put a lot of comments in here so you can figure out what the code is doing at every particular moment.
Would it be hard to scale up the size of that? Or would you have to write a lot of code?
Well, no, it's just that hydrogen has an atomic number of 1 and oxygen has an atomic number of 118. So that's why I did not do them absolutely proportionally. Also, the atomic number is not necessarily the atomic radius, because elements have a different density, which I did not consider. So all I did was make it proportional to the atomic number. But some elements are denser than others. So although the atomic number may be bigger, the actual atom is not.
So if we wanted to print these at double the size that they are now, would that be a lot of code change, or is that just one line of code?
Oh, okay. Here, what I did in this case is I actually gave them specific sizes. I said how wide the radius would be, and I'm so sorry I didn't bring in the thing where I just did a particular element. Let me see if I can actually get that one in. Let me go to external data. Let me get from Access and browse. Let me go to my chemistry.
Oh, there you go.
And let me see if I can bring it in here. Because I did do one that was just specifically for, oh, well, sorry. I think I'm going to have to update this after we're done with this, but I will. I've made a note to update this, to add the report that just draws one atom and it fills the whole page, but I just forgot to bring it in here.
That would just be so awesomely cool, Crystal.
Yeah, that would be it. And then print it to PDF.
Right.
Crystal?
Yeah, and obviously if you're looking at this and you want to render this as a PDF, it's very easy. You can just export this to a PDF file. And I do have these things exported to PDF, but I didn't actually put those PDFs links on the help for this. But eventually I will update that help page with more information beyond just the rewrited syntax I did for all the help that's Microsoft has.
Crystal,
Yes.
you sent a request out to see if we wanted to come to this particular presentation, an AWF. You put out a picture there. There's the smallest element, then you put out oxygen, then you put the heaviest element. Is that what you're getting at as far as the size goes?
Yeah, exactly. Because all I did was I did screen captures from these elements here. And then I went to the last page, which it's just going to take a little bit of time to get there. And then I did a screen capture of this heaviest element.
Okay.
That's in. Oh, go on.
That was in the AWF request for your notification of this tutorial, this session. You sent that out yesterday, I believe.
Right. And who's talking right now?
Jack. It's Jack.
Oh, I'm so glad you're here, Jack.
Jack, do you have a link to that thing you're talking about?
I do. I don't know how to show you because that's where I'm just looking at it.
If you can put a link in the chat.
And you can drop it in the chat. Just copy and paste it into the chat.
Let me just try that. Okay. Got to go to chat.
Crystal, can you page to one of those elements? What were you asking for? A transition metal?
Sure.
I don't know what that would be, but that would at least
Yeah,
show a smaller
transition
version of it.
metals start with column 3. So let me go to like page.
Crystal, I don't know. Can you hear me?
Yes.
Oh, okay, very good. I just want to say, first of all, I am in awe This is absolutely fantastic. But the reason why I'm asking this question is, first of all, just for a little clarity, the number of neutrons in the nucleus is not equal to the number of protons for every element.
Yes,
So-
you're right. And there can be isotopes where
Yeah.
the number of neutrons is different than the number of protons, but in its original form, they were the same number.
Right. I think what you will need to do is probably update your database, because if you're generating these pictograms for use in a chemistry classroom, they're not entirely correct.
Is this Tony?
No, this is you would not know me. I'm a friend of Ben Satrich's. My name is Paul.
Okay, Paul.
Welcome.
Well, yeah, you're right, because I haven't shown isotopes on here, and I'm assuming everything is it's in original form, where that does mean the number of neutrons and the number of protons are the same. But
No,
a lot of
it
the
is not.
elements have different isotopes, and the number of neutrons is different.
Yes, but that original statement that you made is not quite correct. For instance, hydrogen does not have a neutron in its nucleus. Okay.
You are absolutely right. And I did mean to change my code for hydrogen, but
Right.
I didn't. Yeah. Oh, thank you for pointing that
Right.
out.
Deuterium, the isotope deuterium, does have one neutron in its nucleus. The isotope tritium has 2 in its nucleus, but there are many elements where the number of neutrons and the number of protons are not equal in any isotope. So your database may need to include things like the number of neutrons or have some way of maintaining isotopes. But the reason why I wanted to look at something in a transition metal is that the filling of electrons is not linear with the shells.
Yes, you're right. And here I do know that. I do know that they don't always go in order. And I didn't have any good way of knowing what that order would be, because I know sometimes they fill their outer shells and they skip electrons in the inner shells. But I just didn't have a logical equation that I could use to draw these things. So I
Right.
did them kind of just the most simplistic way that I could.
The use of the circle and line drawing and box commands and your mastery of Access is utterly astounding. But if this is, I know this is just a demonstration for our purposes, but for use in education and to make this useful for people to generate on the fly anything to do with the periodic table, there's got to be a way to do that. And the math or the code to do it is just pretty difficult.
Well,
So-
Paul, if you have some links that I can go to so that I can update this so that it is more relevant, because I do want it to be as right as I can get it.
Right.
Just send me an email, crystal@msaccessgurus.com, and I'd love to hear from you.
Okay, will do. Thank you.
Thank you.
Well, thank you.
So any other discussion or questions or requests?
How about praise? This is amazing. This is,
Yeah.
when you're looking for a way to test your knowledge of something, it's always hard to find a good example. And this periodic table is so much data in here, and she's utilizing that data in so many different reports.
Yeah.
And you also using it for drawing too. It's just amazing.
Yeah.
Thank you,
this-
John.
Yeah, I think it really highlights the fact that Access is not just a toy database.
I think, yeah, I'd have to step in on this one. I think that's it's a great illustration of what Access can do that people wouldn't necessarily realize that Access can do. It's data driven mostly. There's code in there obviously, but it's all coming from data, and it's not using controls on report. It's doing everything from these lesser used methods, which
Yeah.
And you know, speaking of that, you might think, oh, line, circle, point, print, 4 methods. What can you possibly do? You know, you only have 4 things to do. But, you know, when you look at the different parameters, you can send them. Line can do a rectangle. Circle can do circles, ellipses, and arcs. And arcs can be open or closed. So you can do so many things with just some simple commands.
Yeah, I think someone requested flashcards, and I'm sitting here thinking, how about mapping?
what?
Mapping, drawing very well. I think initially fairly rudimentary maps, but taking coordinates and creating a map.
And I think Colin, he's not here today because it's still like the middle of the night for him. Although it's the middle of the night for Adrian too, but he's here. Colin's done a lot with mapping, and he can tell you, you know, more about those coordinate positions.
I don't think mapping would lend itself very well to this, George, in as much as that it doesn't. It's not. Maps typically are not organized in standard shapes.
Right. Well, that's the key. Yeah, it would have to be something you could use the basic shapes to do. Yeah.
Yeah, I was trying to figure out how to do a family tree in a similar manner just yesterday. So a hereditary diagram. Still wondering about that.
Well, if you want to see non-standard shapes, I have done a lot. I'm sadly I didn't like capture some of those things, but I've drawn clouds with this. If you go to this web page, and down here on sine and cosine, I've given you a link to a video I did to teach the unit circle, which is basically to teach trigonometry. And in here, I did all kinds of things. Everything was drawn in this video with Access. Clouds, sunshine, all kinds of irregular shapes. Now, I don't give you the code to do that, but I do show you what Access can do that's not regular. If you want to look at that, it's kind of silly, a video, because it's geared toward children. Although many adults don't know these things. So it is kind of a silly video as far as the way it teaches. But in these 37 minutes, if you do watch these, you'll have a great understanding of trigonometry that you maybe don't have now.
Okay. Well, we have gone almost an hour and a half, so I think we'll ask for one more round of questions or comments, and then we'll call it a day.
Did everyone see the link that JDraw posted in the chat? Because it's a bigger picture of a complicated atom. It's not quite as big as it would be if it were on a full page, which would be great to see, but it's still quite it's quite illustrative, quite interesting.
And Adrian, can you copy that chat for me since I can't see it?
Let me, hang on.
Just click in the chat, press Control-A and put it in Notepad.
Oh, you want the whole chat? Sorry.
Yeah, all of the chat, because I forgot to pop it out before this presentation.
Yeah, I have saved it, and I will make sure you get a copy of it.
Oh, thank you, George.
So I think we'll call it into the recording.
Sure.
Month, July, we're going to have a hiatus. It's sort of a tradition, I guess, among the Access user groups. So I'm not going to have a meeting. Actually, I'll be on the road on the day of the meeting anyway, so I won't be. Hopefully, I will be nowhere near a computer on that day. And August, I'm still holding open. If somebody comes along with their presentation that strikes my interest, I might try to get it in August, but as of this point, no. We'll resume again in September, at which point Jack Stockton has agreed to do a presentation on some a method that he has to create codes from long names. For example, if you have the example that I use is if you have a company named McDonald's and you want to create a 3 or 4 or 5 letter code to represent McDonald's, his code will generate M, capital M, lowercase c, capital M. And then if you want to put 4 letters, it will bill it out. So he's going to demonstrate that. And depending on time, he may be able to show us one of the other things he's working on. But on that note, I will say thank you again for everybody who participated. It's been a wonderful experience here. I'm looking forward to getting the database, the ACCDB, and I will see you all come September.
Thank you
Thanks,
very
George.
much, George. I really enjoyed this opportunity to share my love of Access and chemistry at the same time.
Yeah, there's nothing better.
Thanks, Crystal.
Thank you.
Thank you, Crystal. Great job.
Thank you, Ben.
Talk to
Very
you.
cool.